So most of the time when you're watching the weather on TV, you'll see a bird's eye view of a surface weather map. So you'll see fronts depicted like you see on here, but it's important to understand what's going on in 3 dimensions. What does a front actually look like in real life? And for that, I'm going to turn to this diagram here. This is an example of a cold front. Now notice here, again, this is written in 3 dimensions or drawn in 3 dimensions, so you kind of have to look at it like that. We've got the surface cold front located right along the ground, located right here. So you can see the blue triangles indicating what it would look like on a map. You can see the triangles moving from left to right across this diagram. You can also see the arrow behind it indicating the air is moving in that direction. So this boundary, this bubble of cold air that's sliding across the surface of the Earth, is moving in this direction, going across the page here. Ahead of it, you've got warmer air. Behind it, you have cold air. Remember, a front is the boundary between air masses. So I have a warm air mass here, a cold air mass here. This location is 50 degrees. This location here is 55 degrees, but behind it I have stations that are at 42, 39, and even 25 degrees. So colder air is indicated behind it. What does it look like in 3 dimensions? Well, you see the shape of the cold front as it rises up off the surface is fairly steep compared to the warm front that we're going to look at next, because this cold, dense air slides or sinks down to the surface and slides across the surface. It's kind of like if you ever watched pancake syrup or maple syrup move across a pancake. It's a very dense fluid, just like this cold air is a dense fluid. The leading edge of that pancake syrup, as it slides across your pancake, will take on the shape very similar to this. What else is going on here? Well, I've got the warm air that rises up over this cold air. This cold air acts like a wedge. Okay, it forces that air up. And remember from before, if I can get air to rise, I can get the moisture in that air to condense, because air that rises expands. Expanding air cools. Cooling air will condense, and you end up with clouds and precipitation. So usually what you'll see is precipitation right along, maybe a little bit ahead of, and along a front. Behind it, I have sinking air. Sinking air doesn't lead to precipitation, it leads to fair weather. So if I go back real quick, here you can see the majority of the precipitation is right along or ahead of this cold front. Behind it, not a lot of precipitation at all. The air is sinking in here as high pressure moves in. Jumping ahead to the warm front. Warm fronts are shaped a little bit differently. Again, this is a 3-dimensional view, so you can take a look. This is where the warm front would be along the surface of the Earth, as indicated by the circles. You also see that it's moving in the same direction from left to right across the page. Warmer temperatures behind it, 53 degrees. Colder temperatures in front of it, 22, 32 degrees. So I have an air mass change. I have a warm air mass over here, a cold air mass over here, which means the boundary between the two, there must be a front. Since the warm air is pushing into the cold air, it has to be a warm front. If the cold air was going in the opposite direction, if the cold air was pushing into the warm air, I would have a cold front moving in the opposite direction. But notice the clouds are a little bit different here. The shape of the front is a little bit different. If I go back to the cold front, like I said, it's pretty steep. Okay. Looking at the warm front, it's a much shallower, flatter boundary, which means the clouds that form, there's still air that's rising, and rising air is going to lead to expanding air. Expanding air cools. Cooling air will condense. You're still going to get the condensation, but you do so in much different types. Over here with the cold front, these are cumuliform clouds. These are the puffy clouds. They're actually showing a cumulonimbus cloud here. You don't always get cumulonimbus with cold fronts, but you can, especially in the summer. But you get a lot of vertical motion with clouds, whereas with the warm front, you get stratiform. You get more horizontal motions. Yes, they are still moving up in the atmosphere, but not as steeply. So you get more sheet-like clouds or stratiform clouds. So maybe a day or two away from the approach of a warm front, you'll see the high cirrus cloud. Then the cirrus clouds get a little bit thicker, they start to block out the sun, and eventually as that warm front gets closer, you get some nimbostratus and stratus clouds. Notice there still can be precipitation associated with it.